Hello viewers, in today's class we are going to solve yet another a very important and conceptual problem from definite integral, right? And the special thing about this problem is that here we have a combination of absolute value function and signum function, right? So here we have to solve this integral, and we are given this statement, that is integral from -2 to 3 mod of x minus 1 2 raised to signum of x minus 1 dx is equal to p over q square, and we have to find the value of p plus q, right? So what we have to do here, we have to solve this integral, right? And when we'll solve this integral, we'll find the result, and then we'll compare that result with this expression, that is p over q whole square, and by comparison we can find out the values of p and q, and consequently we can find the value of p plus q, right? So let us start. So here let us first take this integral as I, right? So we have the integral from -2 to 3 mod of x minus 1, and we have 2 raised to signum of x minus 1 dx, right? So now we'll solve this integral, and here the integrand is a combination of mod function and signum function, right? So here we have to be careful about these two functions, right? So we have to take care of this mod function as well as the signum function, right? So let us first write the value of this mod function by making use of the definition of absolute value function, right? So now we know that mod of x minus 1 can be written as c. Before writing this value of this mod function, let us see the limits of integration, right? So here we have the lower limit as -2 and the upper limit as 3, right? So here we can draw a number line, and here we have -2, and 3 lies somewhere here, right? Okay, now let us see this signum function. So here we have signum of x minus 1, and here also we have mod of x minus 1, right? So x minus 1 is equal to 0 in order to find out the critical point, or the point where the limit breaks. So x minus 1 is equal to 0, so we have x is equal to 1, right? And 1 lies between -2 and 3, right? So x is equal to 1 is the point where we have to break this integral as a sum of two integrals, right? Okay, so now let us decide the sign of this mod function. So mod of x minus 1 is equal to a negative of x minus 1 whenever x lies between -2 and 1, right? So here we have this interval, that is when x lies between -2 to 1, then mod of x minus 1 is equal to negative of x minus 1, right? So here we have this interval, right? And the second interval is 1 to 3. So mod of x minus 1 is equal to positive x minus 1 when x it lies between 1 and 3, right? So we can write this inequality. So now we have defined mod of x minus 1 in these two intervals, and 1 is the point where we have to break the limit, right? Okay, so now once we have defined this mod function, let us define the signum function, right? So now signum of x minus 1 can be defined as positive 1 whenever x minus 1 this x minus 1 is a positive number, right? So x minus 1 is greater than 0, then signum of x minus 1 will take plus 1 value, and signum of x minus 1 is 0 whenever x minus 1 is equal to 0, right? And signum of x minus 1 is equal to -1, then x minus 1 is less than 0, right? So when these two inequalities hold, then signum of x minus 1 will take plus 1 and minus 1 values respectively, and when x minus 1 is equal to 0, signum of x minus 1 is equal to 0. So this we have written by virtue of the basic definitions of absolute value function and signum function, right? So now if we take this inequality, we see that whenever x is greater than 1, then signum of x minus 1 takes the value plus 1, right? So x greater than 1 implies that whenever we are in this interval, that is from 1 to 3, right, then signum of x minus 1 would be positive 1. And when x minus 1 is equal to 0, that is when x is equal to 1, then the value of signum of x minus 1 is equal to 0, right? So at this point, that is x is equal to 1, signum of x minus 1 will be 0, right? And when x is less than 1, that is when we are in this interval, that is from -2 to 1, then signum of x minus 1 will take the -1 value, right? So now using these two definitions, we can rewrite this integral I as a sum of two integrals, that is I1 plus I2, right? So now I1 is from -2 to 1, right? -2 to 1. So when we take I1, that is from -2 to 1, so mod of x minus 1, see here we have mod of x minus 1, so mod of x minus 1 would take this value, that is when we are integrating from -2 to 1, mod of x minus 1 is equal to negative of x minus 1, and here we have 2 raised to signum of x minus 1, right? So when we are integrating from -2 to 1, that is we are taking those values of x which are less than 1, then signum of x minus 1 will take -1 value, right? So we have 2 raised to -1, right? And here we have dx, and now we'll write the value of I2. So I2 goes from 1 to 3, so here we have 1 to 3, and when we integrate from 1 to 3, then mod of x minus 1 will take plus x minus 1. So here we have positive x minus 1, and we have 2 raised to signum of x minus 1. See, when we are integrating from 1 to 3, it means we are taking those values of x which are greater than 1. So signum of x minus 1 would take plus 1 value. So we have 2 raised to plus 1, right? So this is how we write these two integrals I1 and I2, right? So now we can simplify these two integrals. So 2 raised to -1 is 1 over 2, and we can take it outside the integral. So we have 1 over 2, and we have -2 to 1, and we have -x plus 1 dx, and here we have 2 outside the integral, and we have 1 2 3, and here we have x minus 1 dx, right? So viewers, we have reduced these two integrals to these two simple integrals, right? So now we can write half, and here the integral of -x plus 1 is -x square over 2 plus x, and the limits are from -2 to 1, and here we have 2, and the integral of x minus 1 is x square over 2 minus x, and the limits of integration are from 1 to 3, right? So now we can simply substitute the limits and we'll take the difference. So I is now equal to, here we have half, and when we take x is equal to 1, we have minus 1 over 2, and here we have 1, and here when we take this x is equal to minus 2, we have minus 4 over 2 minus 2, right? So this is the value of this integral, and now we can write this expression. So we have plus, here we have 2, and when we take x is equal to 3, we have 3 square is 9 over 2, we have minus 3, and then we have minus, and when we take x is equal to 1, we have 1 square is 1 over 2 minus 1, right? So now we are having this expression, and we can simplify it, right? So now we have half here, and 1 minus half is half, and here we have 2. So minus 2 is minus 4, and minus becomes plus. So here we have plus 4, right? And then we have plus 2, and here we have 2 3s are 6. So 9 minus 6 is 3 over 2. And here half minus 1 is minus half, and minus plus, so we have half, right? So now this is half, this is 8 plus 1 9 over 2, and this is 2 times this is 3 plus 1 4 over 2, that is simply 2, and this is 9 over 4 plus 4, and if we take the LCM, then we have 9 plus 16 over 4, that is 25 over 4, right? So now viewers, we have obtained the value of this integral as 25 over 4, right? And now we can write 25 over 4 as 5 over 2 whole square, right? 5 square is 25, 2 square is 4, and now here we are given the value of this integral as p over q square, right? So here we are given in the problem, that is p over q square, and now if we compare, we see that the value of p is 5, the value of q is 2, right? And we are required to find the value of p plus q, and p plus q is 5 plus 2, that is 7, right? So viewers, the value of p plus q is 7, and the value of this integral, which is a combination of absolute value function and signum function, is 25 over 4, right? So this is how we solve this problem, and always remember, concepts in mathematics play an important role, right?